Okay, here we are in geometry. We got Unit 3, problem number 101. Nearing the end here. Let's see. Multiply the expressions in part A and B. Solve the equations in part C and D. So, to multiply these expressions in part A and B, I am going to create a generic rectangle. So, we put one binomial along one side, and another binomial along the other. And so here we get 12x squared plus 8x minus 15x minus 10. When we combine all those like terms together, we get 12x squared minus 7x minus 10. It's getting late. I can't even draw straight lines. Okay. 4x minus 1 squared. Again, let's create the generic rectangle for that. So we have 4x minus 1 and 4x minus 1. So 16x squared minus 4x minus 4x plus 1. Combine like terms, 16x squared minus 8x plus 1. Okay. The bottom here we're going to distribute and then we're going to solve. So it looks like we have some binomials here to multiply as well. Let's do the left side here first. So 2x squared plus 6x equals, and now we're going to have to multiply this out. I'm not going to do a generic rectangle. I'm just going to get used to kind of multiplying it out in my head. So we got 2x squared here minus 5x plus 2x minus 5. So if we notice, the 2x squared on this side cancels out with the 2x squared on this side. So we're left with 6x equals negative 3x minus 5. So I'm going to add 3x to both sides. So I get 9x equals negative 5. Dividing both sides by 9, you get x to equal negative 5 ninths. Okay, over here on the last one here, we got 3 squared, which is 9, plus, to multiply this out, we get x squared plus 2x plus 1 equals x squared plus 4x plus 4. X squared here cancels out with the x squared there. 9 plus 1 is 10, so we have 10 plus 2x equals 4x plus 4. So I'm going to subtract 2x here, and we'll subtract 4 from both sides here, and I get 6 equals 2x. Dividing both sides by 2, we get x to equal 3. I realized those last two I didn't write out the generic rectangle when I multiplied this binomial together, or this binomial, or this binomial. Eventually, if you have to do that and you have to write out the binomial, that's fine. Eventually we want you to be able to kind of see those terms multiply in your head. You start to see some patterns, you start to see some relationships and some shortcuts there in multiplying binomials. If you have to write out the generic rectangle for each of those and multiply them out, that's fine. That's what it takes in order to get the problem right, then that's what it takes. It takes a little more time, but again, it's not a wrong way of doing it. I just kind of ran out of room there, so I just multiplied it in my head. If you have any questions about where any of those solutions came from, feel free to leave a comment. Otherwise, as always, you can subscribe, like, or share.